Welcome to the OBX Wave Report for December 7th, 2002. I'm sorry, 2022. My brain hasn't woken up yet. For today, we are tracking a powerful mid-ocean storm and improving surf conditions across the Outer Banks. So, welcome to the Wave Report, where each session is an adventure as we discuss waves, weather, climate, and beach lifestyle. And for today, we're tracking what is predicted to be a powerful mid-ocean storm that is expected to pump out waves across the North Atlantic and potentially, according to the National Hurricane Center, develop some tropical characteristics, which would be a bit odd for this time of year, but given all that we've seen regarding the impacts of human-caused climate change. There has been a lengthening trend or an increasing trend of having storms form outside of traditional hurricane season, and this is in part fueled by, well, and this is largely fueled by warming ocean temperatures. So, and the ocean temperatures out there in the North Atlantic right now are quite a bit warmer than normal. So right now we've got the potential to see this large mid-ocean storm that is forming gather some tropical characteristics. It's not certain that that's going to happen, and even if it doesn't happen, it's likely that there will be a powerful storm out there. It's just a question of whether or not it develops some tropical cyclone characteristics over the next 48 hours, or if it just transitions to a what would typically be kind of like larger broader low pressure system that tends to form in the North Atlantic during the fall and winter months. But the notion of it gathering tropical characteristics is outside of the context of previous climates or the old normal, and we're now living in a new normal kind of situation as the Earth system has warmed up considerably. So, but the main point for surfers and for wave watchers and those who love the beach is that we're going to get some improving surf conditions across the Outer Banks, likely over the next few days. We've already seen that over the past days, and those conditions are likely going to continue to improve. And in our daily wave report for our chosen 3 locations, we already do see that. So I'm going to start you guys off with Jeanette's Pier, and we had some beautiful observations yesterday evening at Jeanette's Pier. The surf was glassy, probably about 2 to 4 feet, with some larger waves rolling in there at Jeanette's Pier. And we got some video of some people enjoying the waves, and that was quite a bit of fun. So check out our videos over on YouTube at Robert Scribbler if you want to see some supplemental video that I put together of the beautiful surf conditions at the Outer Banks yesterday. But for today at Jeanette's Pier, the wave height is, according to the official reports, 3 to 5 feet, with a wave period of 10 seconds for the primary swell and 5 seconds for the secondary swell. Winds are blowing out of the west-southwest gently at 6 miles per hour, and this is an offshore flow here at Jeanette's Pier. And the air temperature is 61 degrees Fahrenheit with an ocean water temperature of 60 degrees Fahrenheit, which is a little bit up from yesterday at 59. It appears that maybe some of the warmer waters from offshore have pushed in a bit, warming up the ocean water temperatures at Jeanette's Pier just a tad. The weather conditions are mostly cloudy, with an expected high of 54 degrees Fahrenheit today at Jeanette's Pier and a chance of rain by nightfall. So we do have some beautiful surf conditions at Jeanette's Pier right now, apparently with wave heights of 3 to 5 feet in the official measure. And for our second location for today, I'm going to go down to S turns off of P Island. And the wave conditions there are very similar. All pretty much all of the east and northeast facing beaches of the Outer Banks, or east northeast facing beaches of the Outer Banks, are experiencing approximately 3 to 5 foot wave heights. And these wave heights are pretty much uniform across all the locations that I've selected, at least in the official reports. So the wave height at S turns is 3 to 5 feet with a wave period of 10 seconds for the primary swell and 5 seconds for the secondary swell. Winds are out of the south-southwest at 14 miles per hour, and this is an offshore flow for the most part, with a little bit of a cross-shore component. The air temperature is 62 degrees Fahrenheit, and the ocean water temperature is 63. So also a bit warmer down there as you just move a little bit further south. Um, it's interesting along the Outer Banks because as you get closer to the Gulf Stream, even by a few miles, it has a major impact on ocean water temperatures, and you can do that just simply by driving down the strand. So S turns is only, I don't know, about 14-ish miles away from Jeanette's Pier, but you have already a 3 degree Fahrenheit difference in ocean water temperatures down there. The weather at S turns is mostly cloudy with a high of 64 degrees Fahrenheit expected for today. And for our third location for the OBX Wave Report, we are going to go down to Hatteras and just going to continue down the strand of the Outer Banks, passing Rodanth and Avon, and we're going to go to the east-facing side of the point over here at Cape Hatteras, where the wave heights are also 3 to 5 feet, according to the official reports. The wave period is 10 seconds for the primary swell, 4 seconds for the secondary swell. Winds at Cape Hatteras are out of the south-southwest at 12 miles per hour, which on the east-facing beaches is an offshore flow. And on the south-facing side is an onshore flow. So just worth noting, if you go around the point, you're going to get those winds turning onshore on the south side there. The air temperature is 69 degrees Fahrenheit, which is the same as the ocean water temperature, at least down there at the beach. If you just get a little bit further inland or closer to the sound, those air temperatures actually drop off a bit. So um, worth noting that the ocean has a major effect, particularly this time of year, on the temperatures at the coastline. The weather is partly cloudy with a high down there at the beach of around 69 degrees. So present temperatures are about as hot, as warm as it's going to get today down at the beach there at Cape Hatteras. So for our wave report today, we are going to talk a little bit about the storm, but before I do, I think I would like to talk about, here we go, ocean water temperatures in the present environment near the Outer Banks. And we have some just interesting conditions here when it comes to ocean water temperature. You have the influence of the continent that is cooling off toward winter. You have a recent rainfall in the region, which is putting some fresh water out into the sounds and bays and estuaries and flushing a little bit of fresh water into the offshore environment. And then you have the general larger long-term context of a warming North Atlantic Ocean. And so these are what's providing the dynamics for ocean water temperature. And the ocean water temperature actually near the coastline presently, according to this model, is a little bit below normal. And this is a sea surface temperature anomaly map. So if I just click here, just right off of um, Jeanette's Pier, the ocean water temperature is about 3 degrees Fahrenheit cooler than normal. And in part, this is due to the influx of some fresh water due to some rainfall, which creates a cap on the ocean and tends to reduce ocean surface temperatures. And you see this effect more prevalently in the sound and on the sound side. But then right offshore here, we've got ocean water temperatures that are in the range of 7 degrees Fahrenheit to almost 10 degrees Fahrenheit above normal out here in the Gulf Stream. And the Gulf Stream is, being fueled by the Gulf of Mexico, which is generally much warmer as well. But then on top of that, you have ocean warming due to climate change. And so this is one of the reasons why you get this real strong swing in ocean temperatures is the across the Outer Banks is the influence of the Gulf Stream. And then the other reason traditionally in climate is you have also the Labrador current, which is coming down from the north, which is a cold water current, or like kind of an eddy of a cold water current. The Labrador current itself doesn't really have a huge influence on the U.S. East Coast, but there's an eddy that comes down here, and it is a cooler water current. And so you get this huge contrast between temperatures in the near coastal zone here in the Outer Banks and the just offshore coastal zone because of that eddy of the Labrador current that comes down and just kind of nudges the Gulf Stream just a little bit offshore. So those are the ocean water temperature factors, the Gulf Stream, the Labrador current, and then the larger context of human-caused climate change driven by fossil fuel burning, which is also just generally warming up the Earth system, the ocean, and the ocean environment here in the North Atlantic. I'm just going to go ahead and flip to a sea surface temperature map so that you can get an idea of the ocean temperatures, the direct ocean temperatures, as opposed to the anomaly conditions. And as you can see out here in the Gulf Stream, it's very warm. It's close to 80 degrees. So you got some ocean water temperatures up near 79 degrees Fahrenheit, just southeast of Cape Hatteras. And even as you're just offshore here, um, off of Jeanette's Pier and Manio and Nag's Head, the ocean water temperature is close to 77 degrees Fahrenheit just offshore. But as you get to the closer coastal environments, you get those ocean water temperatures in the 60s due to that influence from the Labrador current and from the land and from the estuaries, and presently also from the rainfall, which has produced a bit of a freshwater cap that tends to cool off the ocean surface in the regions where the freshwater influence affects it. So that's the reason why we have ocean temperatures where they are right now, and I thought that was pertinent given the fact that it's winter time, and ocean water temperature can be a barrier for surfers and those who like to get in the ocean in the winter time. But it's also worth noting that the ocean tends to be warmer than the land as you get into winter as well. So just some factors here regarding sea surface temperature. Now, going into the present weather situation for the North Atlantic, we are focused in on this bad boy here. And this guy is a weather system that is forming in the central North Atlantic. It's very large, as you can see. The cloud cover stretches all the way from Newfoundland and then all the way down into the North Atlantic, probably over about, looks like about 1,200 miles or so of, well, might even be closer to 1,500 miles. And we have a little wave reporter here, Crow, who's going to be joining us for this session. So But yeah, a storm with cloud cover stretching about 1,500 miles, which is just enormous. And you can also see this satellite shot is from NASA Worldview yesterday evening. Um, so it's a little bit behind schedule, but it does give you a good reference point. And you can also see the massive cloud cover over the U.S. Eastern uh, regions, including the U.S. East Coast at this time. So just a lot of cloudy and stormy conditions both for the North Atlantic and cloudy conditions for the eastern half of the U.S. Now, this storm is predicted to intensify and push a lot of waves toward the U.S. East Coast as well as just out there in the North Atlantic. And I'm going to go ahead and flip here to a weather model that shows the wind structure of this storm in particular, but also the prevailing winds across the North Atlantic. And you can see that this storm itself has a broad wind structure, stretching also about 1,500 miles in the associated winds. And that you also have another broad area of low pressure just to the, well, about 1,500 miles to the north and east of this particular storm that we've been tracking, which is creating a lot of fetch, a lot of long in train ongoing winds over a broad area of ocean for much of the North Atlantic. And this is pushing in quite a swell across the North Atlantic. I think I have a wave. No, hold on. Let's just go ahead and flip to the wave model so we can look at the waves here. And let's go to the ocean surface. And so here you can see the waves just coming in across the North Atlantic. I'm going to switch to feet. So here, just out here in the central North Atlantic, you got nearly 14 foot. And these are significant wave heights. Yesterday I said they were average wave heights. Significant wave heights is the top, I believe, 30% of waves. So the top third of waves as far as height goes. But with significant wave heights, it's worth noting that you can get waves that are double the significant wave height in like larger sets. So if the significant wave height is 13 feet, you might occasionally run into a 26-foot wave, which is worth noting. Now, closer to shore here, of course, the wave heights are going to be lower, which is what we've observed in the range of 5 feet at present. But it's still these massive storms are out here affecting the swell on the U.S. East Coast. Closer into the center of this large storm, we've got significant wave heights in the range of 28 feet and also winds in the range of the 55 mile per hour range in the center of this storm system. So if you have 28-foot significant wave heights, that is very large, and you could possibly see double that in some of the larger sets, which is just crazy if you ask me. But this storm is predicted to intensify as we continue throughout the week, and it is also projected to push out more surf across the U.S. East Coast. And I'm going to just show you an image of the significant wave heights for later this week. This is, let's see, the time period. Um, this is for the 10th, so um, late Friday, early Saturday timeframe. And as you can see, the local wave heights here in the Outer Banks are expected to be in the 8-foot range, which is substantial for this region. And these are significant wave heights as well. And whoa, here we go. With some extraordinary potential significant wave heights for the region where the storm is expected to intensify at 40 feet, which is just insane if you ask me. Let's see, I'll go ahead and update this model. Yep. So yeah, yeah. So and this is a present model here. Just wanted to make sure it was a present model run because I had a very similar prediction from the wave models yesterday, and so it appears that this storm is going to intensify along the um, projected forecast. At least so far, the forecasts are running in line. And yesterday we had a prediction in the wave model of 40-foot significant wave heights near the center of the storm. That would translate to potentially 80-foot waves for your peak waves. So, and this, of course, is near the center of the storm out in the North Atlantic. Although there are some beaches in Portugal, or one beach in particular, where the channel is deep enough where it might catch a swell of this height. So that is worth noting. And switching to the GFS model, I'm going to go ahead and run this model for you so you can see how intense this particular mid-ocean storm is expected to become. And running this model, I ran it earlier and it bottomed out in the range of about 947 millibars is where it bottoms out, which is very intense. Now, it's worth noting that at the time that this storm is expected to be most intense, it is also expected to be in the cooler portions of the North Atlantic. So that's not likely going to be a tropical cyclone. That's more likely to be more typical mid-ocean storm for this kind of year. And so in that case, with pressures in that range, you're looking at wind speeds more in the range of 50 to maybe 60 miles per hour, maybe 70 miles per hour if at the most intense. But where the energy of the storm is focused is more in broader impacts. So you're looking at a very large storm with widespread gale force and potentially storm force conditions across an extraordinarily large area of ocean for this particular storm. So that's what we're looking at. We're tracking this powerful Atlantic storm system that is going to likely increase wave heights in the Outer Banks region. And the models that I've seen both in the offshore and in the onshore for a lot of beaches are predicting waves in the 5 to 10 foot range by the end of this week, which will really be something to see. Now, I did mention the potential for tropical characteristics for this mid-ocean wave maker, and according to the National Hurricane Center, there is still a 50% chance of the storm developing tropical characteristics over the next 48 hours. But then as it gets out into the cooler regions of the North Atlantic, those chances of developing tropical characteristics fall off. So this is worth noting and also worth keeping an eye on if we do have a tropical storm that then transitions into um, a nor'easter or baroclinic style system, then that would be worth noting certainly for this time of year. So we'll just keep an eye on that. Well, in any case, that concludes our analysis of the big potential wave maker for today for the North Atlantic. And I will be out on the beaches again today, providing some short observations. I'm going to grab my new Lost Rocket Redux and I'm going to get out there and try it out. If I have good fortune, hopefully I will be able to. I'm also working on getting my drone up here up and running, and if we do, we'll give you some drone videos. In any case, we're going to give you some supplemental observations, which we'll post directly to YouTube. So check us out at Robert Scribbler on YouTube. And if you want to see some video of the gorgeous surf from yesterday, you can also find it there. So once again, thank you guys for joining us for the OBX Wave Report for December 7th of 2022. I'm going to be signing off for now. but please remember to do everything you can to help save our beautiful shores from the effects of climate crisis driven by fossil fuel burning. And I